Okay guys, today we are going to finish out chapter 6. This will not be on your test. Your reminder, your test is on the Monday after spring break, which will cover chapters 4, 5, and 6 up through method of sections of trusses, but this will be on your homework that you're doing. So today we're going to learn to draw free body diagrams of a frame or a machine and its members. We're going to learn to determine the forces acting at the joints and supports of a frame or machine. Here we go. Here's a reading quiz. Pause the video, take this quiz, see what you think. Okay, hopefully you guys are back and you can see that frames and machines are different as compared to trusses, since they have what? The answer to this one is at least one multi-force member. And then number 2, forces common to any two contacting members act with blank on the other member. Equal magnitudes but opposite sense. So hopefully you guys got those right. If not, go back and read the chapter. It's not hard. Take your quiz too. Applications. Frames are commonly used to support various external loads. They are also, how is this different than a truss? So to be able to design a frame, you need to determine the forces at the joints and the supports. So here we have a joint and we have supports. So we need to be able to determine both of those things. Some other applications that you might see. A machine, these are very simple machines, but machines like those above are used in a variety of applications. How are they different from trusses and frames? What do you guys think? Think about it. The answer here, and the question we might ask ourselves, is how can we determine the loads at the joints and the supports? The forces and moments are required when designing the machine's members. So these are the things we're trying to figure out. So let's look at some definitions to figure out the answers to a few of those questions. So frames and machines are two common types of structures that have at least one multi-force member. Recall that trusses have nothing but two force members. They're all two force members. Some of these have one force members here. So a frame, the difference between a frame and a machine is that a frame is generally stationary and supports some kind of external load. So here we have a frame. This frame is supporting this external load. A machine, on the other hand, contains some moving parts. And so machines contain moving parts and are designed to alter the effective forces. So let's look at some steps for analyzing frames or machines. First thing, this is common, right? We draw a free body diagram of the frame or machine and its members as necessary. So some things that might help us out, we need to be able to identify two force members. The two force member in this is that bar AB. And then we also need to note that the forces on contacting surfaces, which usually means at the pin, and the member are equal and opposite. So you see FAB there broken out. We have an action and a reaction. They have the same magnitude but different sense. And then for a joint with more than two members or an external force, it's usually advisable to draw a free body diagram of the pin. So some good steps. Step 2, we need to develop some kind of strategy to apply the equations of equilibrium to solve for unknowns. Look for ways to form single equations and single unknowns. So these problems aren't easy, guys. So usually when things are challenging, there's several unknowns. So it's going to take a lot of practice before you get good at these, but don't be disheartened. A lot of practice is needed to develop good strategies and ease of solving these problems. So let's do an example. So here we have this frame, ABC, that supports an external load. And we want to find the horizontal and vertical components of the pin B, the pin reactions at C, and the magnitude of the reaction at B. So what's our plan? We're going to draw a free body diagram of frame member BC. So why did we pick this part of the frame? It's because we only have we have more things to work with, right? We have some knowns there. We don't know anything in part BA. Then we're going to apply equations of equilibrium and solve for the unknowns at C and B. So, free body diagram. What does this look like? I'm not going to try and draw this, but you guys can see that we pulled out BC like I talked about. Remember that FBA is going, we're assuming this way, but it also, if we were to draw BA, it would be going the opposite way there. At the pin. So we have some force there. We have this 800 Newton meter moment, we have a 400 Newton force, and then at C, we have CY and CX, and they're assuming down. We're going to assume down in this. So note that AB is a two-force member, which I think we already did. So the first thing that we're going to do is we're going to take the sum of our moments about C. Why would we do that? It eliminates 2 of our 3 unknowns, right? So that makes sense. Sum of moments about C equals 0. So we have negative FAB times 3 divided by the square root of 10, which is 1 squared plus 3 squared gives us 10. So that's what this magnitude is. Times 1 meter. And then we have, so that's our force going in the x direction. And then we also have so if we break this out, we have 2 forces, right? We have FAB here and FAB here. So that's what these two are. So we're looking at FAB in the horizontal direction, and we also have negative FAB times 1 divided by the square root of 10 times this distance here, which is 3 meters in the y direction. Then we have a positive 800 Newton meters and a positive 400 newtons times 2 meters. So then we can solve for FAB. We get FAB is equal to 843.3 newtons. So now we've found the force in AB, so that's actually our force at the pin B. So now we want to go through and we want to find CY and CX. So this is going to be fairly simple, right? So if we bring our reaction back up, we know that this is 843.3. So then we can sum our forces in the x direction. What forces in the x direction do we have in this free body diagram? We have CX, and then we have FAB in the x direction. So we're going to say negative CX minus 843.3 newtons times, remember we're in the x direction, so it's 3 over the square root of 10, and that gives us that CX is equal to 800 newtons, and it actually gives us a negative number, so we assumed CX wrong, so we could just say CX equals 800 newtons to the right instead of the left. The other thing we're going to do is sum our forces in the y. Remember, we only have so many equations, right? We have the sum of forces in the x, the sum of forces in the y, and the sum of the moments about different points. So here, okay, my eraser doesn't work anymore. That's fun. So here, what forces do we have? We have CY, we have 400, and we have FAB in the y direction. So here we can say negative CY minus 400 newtons plus 843.3 newtons times 1 over the square root of 10. So when we've solved that for CY, we get CY is equal to 133 newtons. It actually gives us a negative number, so again, we assumed wrong in both of these instances. So actually gives us 133 newtons, and we can just say that it's going up. So that is how we do frame problems. Do your homework. Come see me if you have questions. We will do more of these in class. But go ahead and keep going. Have a good spring break, guys. Make sure you study for your tests. I'll put a review up either on Thursday or Friday.